Welcome to A Trip to the Planets. This is Megan Prelinger. I'm an historian of space and technology. I'm also co-principal of the Prelinger Film Archives, from which this film was taken. This planetary educational film is a true orphan. Unlike other films on this DVD, nothing is known of its production history. It entered Prelinger Archives from the Mogul Brothers Collection, a group of films from a New York City non-theatrical film distributor. Like many educational films from this collection, titles and credits have been deleted, and sometimes two or more films are assembled into a single work that exists nowhere else. Because of the informational titles, we are calling this an educational film. But watch the multiple styles of titles. At least two styles of titles are in a sans serif typeface, and one is in a bold sepia tone. These sets of titles tell different kinds of overlapping educational narratives as we take our trip to the planets. The huge number of titles in this film will mean that I talk over them sometimes, so excuse me. Take a good look at this spaceship and our astronauts. This set was designed before engineers understood the massive expense associated with large spacecraft. Spacecraft today are small to be economical. These astronauts don't even have protection from gravitational forces, such as seats or seat belts. The electric motor is there in the center of the spaceship. Today we actually use electric propulsion systems that sometimes sort of look like that. More about that once this ship is in the sky. Notice the launch tower and its surrounding space city. The tower in the center resembles Vladimir Tatlin's sculpture titled Monument to the Third International. Tatlin was a Russian avant-garde artist whose works are associated with the constructivist school. We'll see further evidence of Russian constructivism later in the film in the exciting conclusion. But if we learned one thing in the 20th century about launching rockets, it's that nothing works for the launch into space other than chemical rockets. Earth has a very strong gravitational field. To launch a spacecraft into space, the craft has to be powered by an engine that's strong enough to push back against gravity for 100 miles, hard enough to force it all the way out of what's called the gravity well. Currently, no technology other than huge tanks of chemical propellants is strong enough to do that. In the 21st century, engineers are continuing to try to change that to develop new kinds of launch technologies, but for now, chemical rockets are all we've got. However, electric propulsion systems are used to propel spacecraft. Once a ship has escaped the gravity well of Earth, then it's in the vacuum of space and more possibilities emerge. Today, satellites and space probes are routinely powered by engines that use electricity to act on a range of different propellants to produce thrust, to get around in orbit and in interplanetary space.
Could go around the Earth in 1 month. But 340 years would be required for it to travel the circumference of the Sun. Our day and night are the result of the Earth's rotation on its own axis, while its motion around the Sun marks our year.
Let's return for a minute to the question of this film's history. The crazy mishmash of titles are evidence of a very fragmented history. What we're watching may be two or more films put together, we don't know. Thanks to research by Rick Prelinger, we do know that there is no mention of a film matching this title or description in any American educational film catalog of the 1920s or 30s. And the live-action sequences of this film do appear to date to at least around the 1920s. So when I use the phrase, this film, I'm referring to just whatever it is that we are seeing, and not to the film as a coherent work.
Shorter years, while remote ones have longer years. A year on the planet Mercury would equal 3 of our months.
Some of the titles are fairly straight, informative science education. Here they're explaining some basic facts about the planets, although the information offered is a bit out of date. We now know that there are somewhere between 100 and 400 billion stars in our galaxy, and an estimated 50 billion planets. And there are hundreds of billions of other galaxies besides our home here in the Milky Way. We've seen a lot in the sky since these titles were written.
These fixed stars undoubtedly revolves a planetary system like our own. Thus reckoned, there are 1,000 million worlds. Even this is not the limit. If we should stand upon the farthest and dimmest star, we should, no doubt, from there see as many more beyond. We are appalled at the greatness of the universe.
Some of the titles go beyond what we think of today as science education. They offer cultural and religious lore relating to space. For example, here's the mention of the 12 signs of the zodiac system. Interestingly, there is no attempt at all to merge this message with the film's main theme of science education. The constellations in the sky that make up the zodiac system are not shown or even mentioned, just this symbol series. Now the titles are discussing planetary cosmology in a biblical context. Pay close attention to what they're saying as you read. They are leading toward an unusual parascientific theory.
This account tells nothing about the formation of the Earth itself. It says, in the beginning the Earth was, without form and void, shapeless, empty. There were neither mountains nor valleys, trees nor shrubs, rivers nor oceans, but the earth was. How long before that it had been created is not stated. The account of the days of creation given in Genesis relates not to the construction of our globe, but to the ordering of it for human habitation. There are various theories regarding its formation. We follow the most closely harmonizing with the Bible.
The Valian theory of creation. This theory was developed in the late 19th century by an American Quaker theologian and cosmologist named Isaac Newton Vail. He believed that the book of Genesis did not deal adequately with planetary formation. He hypothesized that the planets in our solar system represent God's pre-Earth experiments. He further proposed that Earth was once surrounded by rings like Saturn's. These rings were the firmaments described in the Bible, and that the rings then crashed to Earth, causing the formative upheavals described in the book of Genesis. The materials from the rings created the mountain ranges of Earth. Most likely, this narrative was cut into a pre-existing film, since nothing in the visualizations of planetary science that we are seeing here supports these ideas. This sunrise on the moon sequence shows a striking, sculpted, very mountainous lunar surface with Earth spinning suspended above. It brings to mind the image called Earthrise, the image of the Earth rising over the lunar horizon that was finally seen in real life and photographed in 1968 by the crew of Apollo 8.
Sunlight. In one day on the moon, the distant Earth rotates 29.5 times. Thus, a day on the moon equals 29.5 days on the Earth. But here on the moon, the sun must set, as it does on the earth. Going onward, we meet Venus, who never drops her veil of clouds. We next approach Mercury, whose year is only 88 of our days. It seems that Mercury always keeps the same face to the sun. If this is true, the sunny side of Mercury is too hot for any sort of life as we know it. Its shady side is frozen in eternal winter. Now look back. See those two bright bodies? It is the moon racing around the Earth.
There's the Earth. Now Mars is coming up. It's just about in view. Like another film in this collection, Beyond the Moon, the narrative of this film aims from Earth toward Mars and achieves its destination. Along the way, the film shows us a couple of different views of Mars. First, we see Mars spinning gently in space. Later, we see it in close-up, and the titles mention the canals of Mars. So, a bit of background on the canals of Mars. When Mars was first studied through telescopes in the 19th century, a leading astronomer named Giovanni Schiaparelli of Italy believed that he saw canals on Mars. His preliminary idea was expanded upon to tremendous detail by an American astronomer, Percival Lowell. Lowell studied the so-called canals at length and sketched them in great detail. Later, in the 20th century, improvements in telescope optics changed the scientific view of Mars. Lowell's and Schiaparelli's canals disappeared with the improvements. But the canals of Mars were a potent idea. Visualizations of them were widely depicted in magazines and in literature. The images generated broad public speculation that the canals might be earthworks of an advanced civilization. We don't know exactly when this film was made, but it's likely that dates to a time, the 1920s, when the canals of Mars were still widely understood as factual and the mythology around them was in full play.
Mars, being smaller than the Earth, attracts bodies with less force.
Now the ship arrives on Mars.
A man would seem to weigh much less on Mars than he did on the larger Earth.
The highlight of this film is the ecstatic enjoyment of the astronauts as they bounce around in Mars's low-grav environment, but without breathing apparatus. Even in the 1920s, I believe it was understood that Mars lacks an oxygen atmosphere.
He could hold stones, which he could not even lift on the Earth.
Take a look at the fantastic sets that are portraying the surface of Mars. The bold geometric relief lines that shape the sets are another expression of the influence of the Russian constructivist style. And how about those trampolines? Have a good time on your next trip to Mars, and thank you for listening. Thanks to Rick Prelinger for research assistance.